Good afternoon, good evening, everyone. It's with great pleasure that I'm able to introduce Heather Roberge. She's our Harry Shure visiting professor this semester, and introduce her as the lecturer for this evening. Heather is a highly talented designer and educator. She's the founder and principal of Murmur in Los Angeles, a firm that investigates the spatial, structural, and atmospheric potentials of new technologies as they intersect with the theory and practice of building. Heather is also an associate professor and chair of the Department of Architecture and Urban Design at UCLA. And both her research work, teaching, and practice emphasize innovative approaches to material, to computation in design, and manufacturing as these expand the formal vocabulary and also the spatial implications of building envelopes and assemblies. She's received numerous awards for her work, including being the 2016 Emerging Voices Award recipient from the Architectural League of New York. In 2017, she received the AIA Teaching Award of Excellence. She's been a finalist for the PS1 MoMA Young Architects Program and has received a number of AIA Los Angeles awards for different projects, including the Succulent House and En Pointe installation that she did at the SCI-Arc Gallery, the latter of which very much reconceives the historical and spatial significance of the column, the topic of her current studio that she's co-teaching with Katie Stranix and Katie Casabalas. She's also published widely on her work and research, in particular in relation to her attempts to close the gap, let's say, between formal experimentation brought on by the advancement of computation and design and materials research and the construction and manufacturing process. Different maybe than those who still think the relationship between form and material is somewhat arbitrary. Heather's research specifically speaks to the ways in which technology, material, and form are interwoven. She's been very committed to not only the inventiveness in the development of material assemblies that expand our building traditions and to the craft of making, but also, I would say, to the experiential, sensual, and theoretical aspects of the environments that she creates. She's also one of the most, I think, astute design critics and readers of architecture that I know. Her forthcoming book, Fabricating Plasticity, The Art and Technology of Design with Aluminum, will be published with Routledge, and hopefully I was going to say in the coming year. Is that correct? No pressure, but and lastly, she's a graduate of Ohio State University, and in addition to UCLA, she's also taught at WashU, OSU, Pratt, and RPI. Please join me in welcoming Heather Roberge.
She makes me blush because much of that was hyperbole. I've really enjoyed visiting UVA. I haven't been here that many times, but I'm really enjoying the students and kind of watching them try to decipher what I'm talking about. So thank you to them for their patience and for coming. So before I start, I'm just going to say that you're going to see in this talk a range of design projects at different scales, and that is because that's how I work. In order to distill certain ideas or problems as pedagogy, I often will reduce the scope of design work that students will pursue. So one of the formats in which I teach is called a tech seminar, and this is a place where a technology or a tool or a methodology for working can be directed toward a very narrowly defined problem. So you'll see a couple of examples of projects that are not fully and comprehensively architectural. but have architectural implications. And you'll also see projects that are commissioned projects, which are dealing with the contingencies of building codes and fire, life safety, things like that, typically at a really small scale, typically residential, which is where much of my commissioned work has been done. And then I'll show just a small sampling of one example of teaching just to get at the material and computational experiments that I've done in the context of the university where I teach. So I'm going to start with an attempt to kind of draw together all of these scales of work that happen in these different contexts in order to stake a claim to my work with material. So a medium, in this case paint, is the material or technical means of artistic expression. It's the substance or means of transmission of a force or effect. Painters use a medium to deliver pigments and reflect light in infinitely variable ways. The art historian James Elkin describes the colors on the palette as empty, without form or void, their pure potential, waiting for the movements and light that dispense them across the canvas. Specifically tailored to the effects desired, the distribution of this medium relies on its own intrinsic conditions and a painter's tools. Painters transform visual reception into illusions, evoking qualities associated with other substances. May they be water, wind, or stone in these paintings by Turner. In the post-medium condition, Rosalind Krauss draws together convention and technology with her definition of the idea of a medium to avoid the problem of art's disciplinary boundaries. She states it concerns the idea of a medium as such, a medium as a set of conventions derived from but not identical with the material conditions of a given technical support, which means that a medium is more than just its intrinsic qualities or its technological forms of support. So in Perpetual Inventory, she expands on the idea, saying technical support has the virtue of acknowledging the recent obsolescence of most traditional aesthetic mediums while welcoming the layered mechanisms of new technologies. And as such, it makes it impossible to actually identify the physical support, the kind of technologies behind the work. And so this appeals to me because I am interested in technology kind of ahistorically. So I'm just as interested in technology developed 200 years ago as technology forthcoming tomorrow. So we can think of shifts in technical support in the work of Pollock, for example. He challenges the conventions of painting when he places the canvas on the ground and applies thin paint with particular motions of the brush, wrist, and body. Or here in the work of Linda Benglis, where she pours the medium on a temporary scaffold, solidifying its behavior under the influence of gravity, and importantly, combining painting and sculpture. She overcomes the media specificity of both disciplines and opens up space for new forms of work. Just as one cannot reverse the production of a painting, my projects are synthetic composites of ideas and substances. As architectural inquiries, my work attempts to extend disciplinary knowledge with mixtures of computation, material production, and technical innovation. My design process treats the element of architecture, its form, structure, and space, as different entangled media. And these elements, while initially unformed, are quickly imbued with geometric, material, and conceptual potential. As information-rich, inextricable mixtures, these elements produce singular effects, irreducible to any given material or technique of production. My built projects often explore supple volumes informed by site, program, and spatial ambitions. And the projects often deploy unconventional structural solutions or hybrid structural solutions, fabrication techniques, and bespoke details to articulate their concepts across scales. From drawings to models to full-scale fabrication, digital tools yield precise geometric control of my work, coaxing material into new states. My work embraces a broad array of material traditions from architecture and from other fields, including fashion, ceramics, and metalworking. And each of my academic courses invents a problem, mines its history and contemporary conditions, and directs its possible design futures. These are some facade system projects from a number of years ago. Such projects look to explore particular mixtures of digital description, fabrication tools, and material behavior. And these explorations allow me to apply extradisciplinary knowledge of material behavior and geometry to construction assemblies applied to architectural problems. My references are really broad. The historical, theoretical, and technical all inform the work. And it's my hope that the ambitions that are kind of pursued in the work motivate other people to follow the path further. This is an example of a facade system prototype that's produced in thermoformed aluminum. And because of the particular technology of its production, its stiffness and capacity to deal with wind load and produce a lightweight facade is something only possible with this particular alloy. But things like that, exploring this kind of aerospace technology, open up avenues for production that are outside of the sort of conventional project delivery and manufacturers that we typically rely on. So I'll quickly go through a few projects. I'm starting with small scale projects that are really exploring forms of production outside of architecture and applying them to sort of spatial and effective ends. This project's called Ultramarine. It was a very fast 1 week installation in a gallery in Hollywood, and it was commissioned by an executive director of this gallery called Lace. The director wanted to transform the gallery into a public plaza for summer programming. Ultramarine is an immersive environment of iridescent color. The piece's title refers both to the color of the piece and its meaning beyond the sea. Ultramarine introduces an abstracted synthetic vision of the Southern California landscape into the gallery. It's at once the clear blue sky and shimmering rhythmic surface of the sea. The installation produces the physical sensation one feels when viewing a cool body of water. Like the sea, its surface appears to be in a state of flux as the fabric curls and drapes in unexpected ways. The piece was conceived digitally and produced manually, just using large plotted templates and applying garment making techniques to alter the lengths of the fabric along the top and bottom edges of a series of fabric bands. So these long sheets of contoured fabric were darted and stitched to choreograph both a general underbelly of the piece as well as its local flounce, which are these undulating conditions that occur within the piece. So to switch to a different scale, this is the only teaching example I'll show. This is called Exercises in Plasticity, Retooling the Mold. And this was taught with a design media artist in a media arts department at UCLA. And she and I decided we would explore casting and its typical association with repeated serial parts. We were trying to stake out a position that would acknowledge the efficiencies of casting and repeatability without falling into the trap of producing singular repeated parts. So with the widespread availability of numerically controlled manufacture, design at all scales increasingly relies on mass customized parts. And these parts often respond to digital parameters more readily than material parameters. Design therefore is increasingly more responsive to new technology instead of tradition. So we designed this research project to try to combine craft traditions and digital techniques to produce non-uniform seriality. So despite the promise of 3D printing, casting provides more durable, more quickly produced, and economically produced parts. And so beyond the known advantages of serial production, we are able to minimize waste when instead of making endless variation, we're also able to produce more durable parts. So our claim was that casting and its required tooling, its molds, have received little academic attention, despite their central role in the production of seriality. So when considered in light of computation, the mold offers opportunities to rethink seriality and its possible plasticity. So the digital turn has laid claims to lots of different positions about part to whole. What we were interested in doing is to produce some economies while also innovating ways to produce difference in mold making. This was a student project that preceded this course that inspired me because the students were interested in prototyping tilt-up concrete walls, but were interested in producing a kind of combination of standard pan cast elements as well as fabric formed parts. So by producing a jig with variable bounding conditions, they were able to produce doubly curved panels without producing multiple molds. And so this was an example that they cast. So we wanted to scale down and apply this to the problem of the vessel. So our project proposes a work on the mold such that we can produce variation without reproducing molds each and every time we wanted something different. So we pursued two lines of material investigation. One was slip casting, where you use a porcelain slip and pour it into a mold, which is made of plaster, and that plaster mold removes the moisture from the slip, and you're left with a clay body part that you can dry, fire, and use. And we also looked at urethane casting in rotational molding. So we basically were looking at molds that could be completely closed. A resin could be slushed around in that mold, and then we could unfold the mold and release the part. So both of these kinds of molds, we asked the students to make a mold that could produce more than one part. So they were limited to just one mold, and that mold needed to think about part removal, potentially interchangeable parts, and the release of the cast object, which is one of the formal constraints of casting. So first, students studied the historical development of hand-built, thrown, and slip-cast ceramics to understand their formal components and the impact of material behavior and production on vessel silhouette features and their serial production. And so we first looked at early Greek classic vessels. I think there's something like a dozen of them, and they all have different ceremonial uses, and as a result, a series of different feature sets kind of emerged in the production of classic vessels. So everything from the base, the stem, body, shoulder, neck, handle, and rim, these are all kind of components that change their expression as the ceremonial use of the vessel changes. And so we looked at some cases. This is a kind of improvisational rotational molding machine that someone runs with a drill. And there are a series of developed patterns on the right that are used to produce a series of molds. Each of the proposals proposed a series of cast vessels from that one innovative mold, and static molds were reconceived as responsive molds capable of adaptation. The resulting cast objects explore plasticity, creatively circumnavigating the rigidity and identical repetition of the mold. So I'll talk specifically about just a couple. The first is called Dark Opulence. It was designed using a developed mold of tessellated equilateral triangles that included 4 possible three-dimensional configurations. So basically there's a very specific flat sheet of silicone that can be folded up and closed in 4 different ways. And depending on the folding instructions used, the mold configuration differs in both volume and silhouette, and the resulting cast changes form, orientation, and relationship to the surface on which it rests. So there's some material experiments here. These are just powdered pigments that the students brushed in kind of gradient ways across the silicone sheet. And then they produced each of the 4 configurations of that mold in 3 dimensions. And the closed cast was then cut in order to access the kind of interior chamber of the object. So the orientation of the vessel couldn't be predetermined. It was a factor of the center of gravity of each of the particular casts. And so each of the objects kind of rests in a particular way, and the flat base, which one might associate with the Greek vessel, is replaced by a series of kind of sharp feet upon which, like a stool, the vessel balances. And instead of determining the static orientation, the vessel basically, with its own center of gravity, finds its relationship to the table. In this case is a slip cast experiment. The students designed a 1-part open mold and used this work to explore fluid dynamics of the slip as it moved across this a CNC-produced topographic surface. So the mold surface began as a series of 2D contours, closed contours, that describe 9 different concave chambers. And these chambers produced a wide variety of vessel forms. So some were more bowl-like, some more cup-like, and the kind of angle of inclination of each of the surfaces of the mold varied. The design ingenuity in this one was the relationship between the units and the topographic surface in which they reside. So the design of the mold choreographs the flow of the porcelain slip across the mold surface, following multiple trajectories and originating in different fill points. So you could basically move your entry point into the mold around across the surface, and depending on where you began to fill the mold, you would have different configurations of vessels. So the mold channels the fluids from unit to unit as the level of the slip rises, and the contours used to produce the cells produce different kinds of rims. This allows the vessels to have different numbers of compartments, different kinds of composite series, and different rim widths and configurations. So typically a one-part mold will give you a simple plate or a bowl or a cup, or especially a platter. But by studying this, kind of using the tools of describing topographies, the students were able to produce these kinds of variations. And the project incorporates the potential for many vessel forms in one ingenious mold. So they ended up producing 30 different types with this one mold, and I think went a long way in proving that there's quite a lot of work that can be done on the mold in order to escape this sort of individual bespoke part that we might think is available through 3D printing, but still produce a kind of geometric sophistication and a kind of potential difference without resorting to 30-hour production times using 3D printing. So this can happen in the course of 30 minutes. So next I'll show a commissioned project. This is called the Vortex House. This was the definition that served as the conceptual diagram for the project, with the ambition to kind of rethink the relationship of inside to out. So when you live in Southern California, you visit many case study homes, you quickly come to believe that particular diagram for relating inside and out is exhausted and incredibly captivating, and we can't do better than that. So we have to come up with a different idea about how to relate inside and out if we want to change the expression of the house in that Southern California context. So this house occupies an excessively regulated site on the bluffs of Malibu. It's about 1,000 feet above the Pacific, and its hillside location presents stunning views in all 360 degrees of direction. The project's ambition lies in its dramatic spatial modulation and the saturation of its interior with the visual and geometric material of the surrounding site. So rather than understand views as a way to release the interior to the exterior, the surrounding geometric and topographic features are drawn into the interior to condition its atmosphere. So artificial and natural geometries are characterized as of the same fluid medium and the house a vortex into which this material is drawn. So the house is really deeply site specific. I don't think this house the ambitions of this house were just motivated by this site, and so I find its form and organization kind of inextricably linked to this dramatic site. And the house basically has a 5-sided organization, which you can see in this site plan. It has a open to the sky, open air court at the center of the building. And this, it also has an exterior space that's involuted into the plan of the house. So the roof covers a large exterior patio, which is facing southwest. So the folded roofscape rises and falls dramatically, modulating the living spaces beneath it. The roof perimeter is typically low, and the center is high around the perimeter of the exterior court. This locates the ceiling of every room in the foreground of the unfolding landscape views that envelope the house. So along the bottom of this slide, you'll see a series of images where you're always seeing the ceiling as part of your field of view wherever you are in the house. And I'll return to the plan in a little bit. So the exterior wrapper defines a kind of top building form with these involutions I mentioned of exterior covered patios, which help for the kind of climate of the house. And the exterior wrapper is intentionally lengthened by the 5-sided building and these involuted patios. And that allows every room to have at least 2 faces of exposure to the surrounding landscape. And like the top profile of the wall, the windowsill also kind of follows some of the cues of the landscape and allows us to move from window to door and kind of tie apertures into longer, expansive openings. On the bottom of this slide is an unfolded view which shows the relationship of the window apertures, the top of the wall, and the landscape that you see beyond. So from the northeast to the northwest, the ground rises very quickly. So for 180 degrees of view, you're basically in a bowl of rugged mountains, and in the other direction you see the Pacific 1,000 feet below as a kind of panorama. So you have 2 really different spatial conditions made by the perimeter of the site. The house is constructed of 2 structural systems nested within one another. The steel frame draws the spatial modulation of the interior and stiffens the folded roof plane, and conventional timber framing infills the frame, stiffening the wall and stiffening the roof plane, and that allowed us to produce the frame without the demands of resisting seismic loads. So in this case, the spatial ambition of the house is impossible without the use of this structural hybridity, at least in a sort of economically feasible way. And force follows material, so uncommon distributions of material require structural ingenuity. In this case, the 2 systems are collapsed, allowing force to slip back and forth between them. So there's some details which I won't go into a lot of into really specifically, but we use the window locations and the central courtyard to help with passive cooling so that the client doesn't need to run the air conditioning year round. And the roof is made of zinc, so Despite this area not allowing gray water, we've basically allowed the system to be updated later by choosing materials that would allow us to use rainwater harvesting from the roof. So I'll quickly walk you through the project. I'm going to begin at the top of the slide to the right, which is the entry of the building. The roof slides out, and basically you slide into the house through this front door. And there's also a kind of independent entry for the client who's a psychotherapist and was hoping to see fewer and fewer patients from the comfort of his den. And then when you enter, this is the view toward the west, so you can see the Pacific sort of straight ahead and to the left. And through the rear door, you can start to see the landscape lift as it moves around the back of the house. And in this particular view, you see a place where the steel frame slides out of the building and is basically duplicated because of the span that we have in that location. This is a view where you see the courtyard to your left and the ocean to your right. And the space that you see on the oblique with the lounge chairs is basically the covered patio, which is facing the panoramic view of the ocean. Here from the kitchen, you can see out the front door to the ridge lines beyond, and to the right you can see the Pacific. And so the courtyard provides kind of daylighting in the center of the house, and it's basically the object that you move around in order to access the private spaces of the house. So the courtyard is number 10 in the middle, and we'll walk back around that where the space becomes very vertical and tall, and you basically slide along the courtyard and you can move to one of the 2 bedrooms that the house has. The den is on the left and the master is on the right. And as you walk, you can see through the court and to the landscape on the opposite side of the house. So the rooms that line that courtyard basically have oblique views that slice across that court and bring the distant landscape into an interior that's on the opposite side of the house. This is the den for psychotherapy. This is leaving the den. You can see again the west side of the landscape from the east side of the house. And then we're coming into the master bedroom, which is on the right-hand side of the slide. And you can kind of see the hillside start to drop into the ocean again. And the house kind of returns to where it begins through this exterior patio. So if you want to open the doors, you can basically circumnavigate the house and the site and return to the kind of family room. I lost every battle in the kitchen, but instead of photoshopping it away, I just own it. The house is also lifted on a crawl because the client is terrified of snakes. So we lifted the house up off of the ground and used the crawl to distribute some of the mechanical systems. And then we also took all of the gutters to the perimeter of the deck so that this elderly couple could take care of gutter cleaning and everything at the ground, so they never had to climb a ladder in order to take care of that. And as a result, the house has really crisp edge conditions, and you don't see any eave overhangs or any gutters, and that closes up all the eaves to the kind of surrounding wildfire-prone area where this house exists. I guess I could say, and computationally, we had to build all the curved walls and drive them to the site for installation because it was a labor of love. This is another commissioned project. This is called, much less interestingly called, the Gatens Chan Residence. I don't know what to call this one. This was commissioned by a screenwriter and his family. It's an addition to their sprawling mid-century ranch, and it contains a private writing studio, a guest bedroom, and a garage for a classic car collection. Inspired by the iconic butterfly roof, the project features a hovering angular volume that responds to program height restrictions and its dramatic canyon setting. The upper story of the building is cut to reveal interior volumes and to produce an exterior balcony for circulation. And this butterfly roof basically redirects the interior toward different conditions, like up the canyon and toward a stand of really large old redwood trees. These offer two views, one from the interior side facing the existing house and one from the alley side facing the sort of back, the fronts of other homes. We used a bow tie plan in order to allow for views obliquely down the alley so that the client could look beyond existing houses and along them instead of directly frontally at them. And it also allows the guest quarters and the screenwriting room to have views in different directions, but not directly into one another. And then this sort of bow tie plan also allows us to have the roof directed in different directions. And shared in between those two spaces is a shared bathroom. So if the exterior space is brought into the building volume in part to reduce the apparent mass of the building and to allow for some exterior spaces that could be occupied at the second floor of the addition. This is basically the sequence from down below. There's a connection to the house through this stairwell onto a balcony here. And then there's a separate entry into the guest quarters on the right and the screenwriter's studio on the left. We have a skylight that brings natural light deeper into the floor plate of the building. And then on the right, you'll see a guardrail that was a kind of custom designed guardrail that I'll talk a little bit more about. This is the screenwriter's space. This is his oblique view of the redwoods and the balcony view of the kind of hillside beyond. And this is the guest bedroom oblique view over the top of the pool straight ahead. So the balcony was designed as 2 layers of folded perforated aluminum. And its folded layers eliminate the need for a perimeter frame and obscure the expression of the structure of the guardrail. The resulting lightweight assembly explores the visual moire effects of the 2 perforated sheets and the tectonic and material advantages of folds. So this is a kind of study of the relationship of the posts which hold the upper guardrail beam and the relationship of the layers of the guardrail to that. And they're just a series of offset folds that stiffen what's otherwise a pretty pretty thin sheets of aluminum. This house, called the Succulent House, is pretty old but incredibly relevant, I think, in a couple of weeks after the UN climate change report. So I dug it out of the archives. This Succulent House was designed for a book called 306090, and the editors of that book tapped a few architects, about 7 of us, and asked us to respond to a crisis of the American house. And so I typically am not a crisis response designer, so it was really a struggle for me. But one of the crises that I had identified was the sort of greenwashing of a typical suburban house in order to change its environmental performance. And I was interested in exploring an approach to environmentalism that was more organizational and didn't rely on the purchasing of technology upgrades and equipment upgrades to change the performance characteristics of the house. So this was my response to the crisis, to what I identified as a crisis. So the American house is experiencing a deepening crisis of identity in an era of growing environmentalism. The identity crisis began nearly 60 years ago with the end of the case study house program and the rapid acceleration of suburbanization. And the discipline of architecture never regained its footing in the context of the American house, as the house became a product subject to the efficiencies and economics of mass manufacture. The impact of suburban infrastructure, of suburban sprawl on energy, water, transportation was largely overlooked until the geographic consequences were firmly entrenched. So growing environmentalism has done little to assert a new identity for the American house. Whether produced individually or en masse, the American house remains a mixture of old forms, updated equipment, and engineered building products that mimic long-abandoned methods of construction and long-discarded lifestyles. This critique applies as much to the tract home as the dwell modern mid-century remix. Neither solution comprehensively addresses changing societal values or contributes significantly to contemporary design culture. So we make the argument that we have an audience of environmentally minded people who are willing to pursue product upgrades and supplemental equipment, but this approach is insufficient in its impact and the rate of change too slow. So instead, we propose this approach to the design of an environmentally concerned building. We call it the Succulent House, and it addresses one issue of sustainability, which is water supply. So this is one view of the interior of the house. These are expandable bladders that collect water from an inverted roof that drains into these bladders. And the bladders change shape based on the rainwater cycle and your water use. So it makes tangible both how much water has fallen and you have collected and how much you're using. And the idea is that rather than using subterranean cisterns or above ground water tanks or plastic rain barrels meant to look like wood barrels, we can instead learn from the kind of the storage capacity of a succulent. So we decided to design a house for a particular place. We just chose a kind of interbeltway site in western Chicago. And we did an analysis of its rainwater cycle, lot size, roof catchment area, and designed the kind of storage system according to that particular site. But our idea was that this system would be redeployable and you could produce different configurations of house specific to its rainwater cycle context. So our prototypical urban parcel, it measures 50 by 110, which is really similar to the kind of conventional parcel in Los Angeles. And the roof is divided into two parts, both with a kind of central kind of hole where the bladders are lining and collecting water from the roof. And one in the back, we have a kind of master bedroom, kitchen area, and in the front, we have living and additional bedrooms. And the plan basically takes the configuration of a figure eight, and that allows the sort of rainwater storage bladders to be visible from two sides because they're typically located in the center of the building. So in the front of the house, which is down, the storage bladders cascade from the modulated ceiling to line the more public living spaces, and in the rear, they surround a winter garden between the kitchen and the master bedroom. Our proposal argues that performance is not measured by quantitative methods alone. We draw on rainwater harvesting in large part because of its impact on the spaces we propose. Like its namesake plant, the bladders exhibit succulence in times of increased water supply, and in times of low supply, the bladders are loose and drapery-like. As the bladders fill, the reflective surfaces capture views of adjacent conditions, optically collapsing spaces into one another. And the succulent house alters the form and atmosphere of the house by integrating rainwater cycles into the rhythm of everyday life. I'm going very long. I'm going to speed up. I'm going to talk very quickly through this one. This is called A Room with a View. This one's under construction. It's also called the Periscope House. It's a tiny house where we're doing an addition in the flats of LA, adjacent to stunning hillside views. And if you know anything about Los Angeles real estate, when you're in the flats, your real estate values drop compared to being in a hillside area. And so this is an attempt to kind of smuggle the views and scenography of the hillside area into a house on the flats as a way to produce a room with a view. So we use a periscope that basically is a clerestory that pops out of the roof. It has a sloped ceiling, and that sloped ceiling has a mirror that reflects a view of the distant hillside into the master bedroom, which is at the rear of the house. So this is a rendering of the periscope, which is at the top portion of the screen, and then you see the hillside view in the reflected mirror that you see directly in the center of the view. And then this project also deals with the sort of traditional construction of a raised floor construction and its difficult relationship to the ground plane and the outdoors where families like to congregate in LA. So there's a kind of split level resolution of a split level condition between the existing house and a new series of pavilions and pool that exist in the rear. So I'm just going to slide quickly through that. The Periscope is basically a gap between the old house and the new addition. We have an outdoor dining room that we're constructing and a guest house and kind of pool patio in the back. This is kind of the space we're making between some of the existing structures. And this is a view from the existing house walking toward the rear of the project. And that's again the view looking back at the existing house. So now I'm going to skip this and end with a column project because I have to. Here we go. So this is an installation that I designed for the SCI-Arc Gallery, and we had help producing the parts and assembled the project with a group of students. It's called En Pointe, and it reflects on the historical and spatial significance of the column as both object and series. It's inspired by the hypostyle hall. It's a group of columns poised on blade-like fulcrums, defining dynamic space below. To achieve the balanced state, the mass and silhouette of each column is eccentrically distributed, meaning non-axially distributed, to stabilize adjacent columns. While unstable individually, the columns enter a state of poise when grouped. En Pointe therefore challenges qualities long associated with structural and visual stability, proposing alternative distributions of force and material, and with these reconfigured spatial experiences. The column has long been a site of architectural study and ingenuity. As both object and part of a larger series, it's at once symbolic and functional. Its verticality marks the distance between horizontal planes, and as it's repeated and repositioned, it determines spatial order. Its status as an object is marked by variations in silhouette, massing, and termination. This installation expands the potential of the column conceptually and materially. Conceptually, En Pointe inverts the column's relationship to the ground and intensifies its spatial effects. Its tapered silhouette challenges the long-held notion of fermitas, originating with Vitruvius, as a necessary expressive quality of the column. Instead of visually stabilizing each column with a broad base, En Pointe develops visual stability through interdependence. The individual columns enter a stable state through the adjacency and specificity of its neighbors. This is a view from the mezzanine. The SCI-Arc Gallery is a 2.5-story space, and it's surrounded on one long edge with a catwalk. So whatever you install in the gallery is seen from above in kind of bird's eye perspective and from within the gallery. And so you have these different vantage points to continue when you're working there. The figural space between the columns expands and compresses in relation to its structural choreography. Materially, En Pointe's folded aluminum panels are enclosure and structure. This invents a column type located between the surface active structure of Felix Candela and the section active structure of Mies van der Rohe. Produced without molds or an internal frame, the columns reveal the material advantages of lightweight shells. Underlying the exhibit's development is an active engagement with history as a deep reservoir of insight into the nature of the column. The exhibit featured an extensive collection of historical and contemporary case study projects, highlighting the column's role in architectural innovation. We included in the exhibit this genealogy that compares and contrasts various articulations of the column to reveal changing notions of space, hopefully provoking thoughtful speculation on the nature of the column. En Pointe drew on these insights to cross-pollinate historical cases with one another, proposing the first of what we hope are numerous possible futures of the column. Its design and fabrication relied on both mechanical and digital tools. This is a kind of array from sort of old technologies like the rubber mallet and a rivet, and newer technologies like finite element analysis and the largest laser cutter I could find in Southern California. We tested its structural principles using Unity, which is an open source video game engine, and it has a physics simulator. So by running repeated simulations, we tested the stability of different configurations of columns. This is my low-tech animation. And I have real ones, but they never run. So the one to the right in the middle was version 10. It stood up, so that's what we did. We also use Grasshopper to determine the center of gravity of different columns to help us with the design. And we built half-inch equals a foot models where we would put the weight of the column at its center of gravity in order to test its rotational characteristics. So we did all these interesting kind of physical and digital models to see how the project behaved. And then the engineer studied one column and said, that's going to work. And I said, but you didn't study all of them together, which was very strange. So then he studied all of them together and he just did a finite element analysis model, and it was fine. So we decided to move ahead. And he said, you should really prototype a full-scale column. I said, that will cost me $5,000. And he said, you really should. And I said, there's no time for that. So we used this series of drawings, the tops here, which behaved as a diaphragm linking the columns together, a series of triangular wastes, which helped us to modulate and choreograph the route through and under the columns. And then these were the kind of rectangular fulcrums at the base. We used those to try to control which way the columns would fall if they were going to fall, so we didn't have to design in every direction. And then we, using Rhino, unfolded the drawings and added bend allowances for the break forming we planned to do. And one of the techniques we used is called bump breaking, which means you make very small degree folds iteratively in a sheet material, and you can produce curvature that way. So all of these are developed and only folded along lines, but that allows us to produce curvature and faceting. This is just a piece that sort of shows the way the patterns became three-dimensional. This is sort of assembly section of how we built the project. We built like 65 parts, and we built the tops as whole pieces and the bottoms as entire pieces, and then we mated them in the middle with a series of bolts. I'm still not sure how we did that. We built them upside down, and because I'm small, I bolted them together in the interior, and then we flipped them upside down. And no one died. So En Pointe is visually heavy and physically light. By tapping into Southern California's rich manufacturing context, the installation explores the advantages of lightweight construction. En Pointe rejects structural optimization in favor of nonlinear load paths that defy tectonic expectations and shape spatial and circulatory sequences that are immersive and cinematic. Rather than privileged fixed vantage points, the installation encourages exploration in motion from within, beyond, and above. En Pointe scale and sculpted interior choreographed the posture and motion of its visitors, melding object and subject into one intertwined ensemble. Thank you. Sure.
Open it up for any questions?
Well, first of all, thank you for a great lecture and beautiful titles.
Thank you.
I'm a huge lover of well-thought titles, so I really enjoyed the titles of your projects.
Thank you.
At the beginning of the lecture, you mentioned the case study homes, and in many ways, the case study homes and many of the mid-century homes of sort of within the Southwest of California had a very particular approach to appropriating nature and making it part of domestic life, right? And in many ways, when we look at the first house you presented, there's a beautiful attempt to create more of a panorama, but a much more mediated, and in many ways distant relationship between interior and
Instead of bringing it to the
it
interior.
reminds me of the National Gallery, right, in Berlin, right, where sort of the backdrop is suspended between the floor and the ceiling, even if it's in suspension or in tension. And I wonder if you could speak a little bit more about sort of the way that you use landscape to be able to articulate these mediations and effects.
Well, really good question, and I have to rethink how I talk about it. I always felt like a mid-century house was deferring to the beauty of the outside by appropriating it. And so and it's very stressful as a young designer at that time I was younger, doing your first house in such a charged environment with such talented people working and with this staggeringly beautiful history. So I think I told myself that the fire codes are really different now. The kind of seismic design criteria are so different. So you have to actually suspend the idea that you, for a middle-class client, can cut away massive portions of wall. So that was just kind of how I spoke to myself to calm my anxieties about trying to work in a staggeringly beautiful place. And then I think that there were lots of political issues with the house, which I don't talk about that limited the volumetrics of the house, and we needed to convince the city that we were making a modest, small house. So all of these competing issues basically dropped the perimeter of the house to make it look very small and modest. And then once we did that, I realized that I had sort of implicated the ceiling plane in the views. And after that, the concept became clear, and the other things like built-ins and windows started to chase the concept. But I have to say, it's probably bad to admit, but there are certain oblique views that I knew I had achieved in the plan, and others that were far better than the ones I thought I had done. So the courtyard, I hadn't realized how wonderfully aligned the master bathroom window was to the most dramatic ridgeline. So I think a couple of cases were accidents, like actually unknowable until the wall was up. Most of them I knew, but some of them were accidents, which I probably shouldn't admit, but I knew to photograph them. Okay, good. I haven't built enough to know if it happens all the time. The battles? Oh my gosh, you can't tell? I lost the battle of the kitchen hood, the kitchen backsplash, the countertop material, and all the fixtures. Yeah.
Well, I'm really intrigued by how you describe your projects as kind of inversion of expectations. But I'm particularly interested in the installation of the SCI-Arc, the inversion of the column,
Mm-hmm.
and the idea of people moving through space. But I have two questions about it. One is you showed all your photographs are empty of people, and yet your whole discussion.
I know.
So I'm interested in that. But the other is all of the construction techniques and the software. And I'm wondering, what do you need to know to be an architect?
You have to know everything.
Yeah.
Yeah. I often in faculty meetings say achieving competence is really difficult. We should try really hard to do it because I think the biggest advantage of being an academic is that I'm a perpetual student. So in any given project, I don't know it's not like I go into a project armed with a technique ready to deploy. I'm really working on something, and then I find a technique that's going to be able to achieve it. And I do a lot of research. So the book that has been sitting in a digital folder for a long time was doing a lot of research on metal fabrication. And I've worked enough that I knew a lot about metal press brake forming, but I hadn't realized that computational control of press brakes mean that it's not by trial and error, where obviously none of the brakes there were the same angle twice. And so with CNC controlled brakes, it's able to take the gauge of the metal and apply exactly the right pressure to produce the fold you need. And the tolerance is really great. So we only sent back like 3 parts for additional folding because they weren't quite tight enough. But we would have never been able to do that without numeric control of the machine. It would have been just far too expensive because you would take it off the brake, test its angle, put it back on, knock it a little bit more. And in this case, the plugging in the material parameters and the desired angle gave you the brake you needed immediately. And so that allows for a complexity of folded surfaces that you couldn't economically achieve in a traditional model. So it's really this old technology, which was done with hydraulically and just kind of through the knowledge of experience and craftsmanship. And it's now calculated numerically, and you can control it with high degrees of tolerance. I don't know if I answered your question.
The entire presentation, and particularly at the end in terms of inversion, I could imagine giving this talk again, or you giving this talk, with beginning with that SCI-Arc project and the evolution, and even that you constructed it upside down because of gravity, right?
Right.
Yeah. And then you put it and turn it, so it's questions of inversion. And then I thought back to the very first, I think it's the Malibu house, the one with the incredible landscape, and how the ceiling itself, which usually is the quiet frame for all the figures out there,
Right.
suddenly takes on. And then I said, oh, the next time you build it, you'll do it with light skins folded around the construction, like the column.
Right.
You had a column coming down and then a beam, but then
Right.
a column on the outside.
Right.
And I want to follow this column and put it in.
Really
So
good
all
point.
The lessons from this one project could go and reconsider instead of sheetrock or whatever,
Yeah.
the panel or even the railing, which was terrific. So it's great that you can give a lecture in the sequence, skipping type A, I guess, in that.
Yeah.
We'll have to wonder about that. And then, and say the end and that project itself, and how it is stabilizing. And I think Joseph Reckworth, one of those older people of another generation, said, began explaining columns around the Parthenon when columns dance because human beings dance before they ever, so that support is there. So it goes back to your research on history, and I think, and Cordova, which are really dancing instructor over there. So it's great to see a lecture of an evolution of work, but this early one could begin and the same, another story could be told. From
Right,
that. I
right.
appreciate the honesty of your discovery.
Thanks.
I have a
Hi, Mona.
Thank you. Hi. So it's a little bit of a reiteration of what was asked beforehand, but I'm interested in the technique of design because it seems extremely rigorous on the one hand side, but then at some moment it becomes intuitive, and I have the feeling the painter takes over. And I recall the first slides that you showed, where the technique of mixing the colors create very different atmospheres. And the same with, for example, the Malibu house, where on the one hand side you can understand it's all about the inside and outside, but then there was this picture where I thought the roofscape is actually a citation of the landscape that sits in the back. So then I'm assuming, but maybe I'm reading the work wrong or in a different way, that there is this tension between using on the one hand side very rigorous design techniques and tools, but then at some point there's also the craftsmanship of sketching in a book and taking it over. And I'm interested where, if this is the case, and if so, where these tipping moments are happening.
Well, I think that's a really good psychological read. I mean, I think I'm probably far more intuitive than methodological, and probably no one believes that because it appears like I try to set up methods and I'm really prescriptive, especially in tech seminars about working. But I'm a painter that wasn't allowed to go to art school. So I think I'm really painting like in 3 dimensions. So to me, I really like making models and looking at light and tone and form, much more like someone who loves to draw or loves to paint. But I also am really comfortable sort of incorporating the conditions of human beings, like how do they want to live, how do they move. And so the question I didn't answer about there are never people in the images has to do more with a lack of, it seems like I'm always exhausted when a project is done and I don't thoroughly plan how to document the project. And so I think the fact that there aren't people is absolutely no reflection of the fact that I don't consider people. It's just, I also sort of like the abstraction and purity of photographing something without them in it. But I love to watch people be in a project, but I don't want to show that slide a lot of times. But I often get that critique that you talk about this perceptually and in terms of its physicality, and you never show anyone. Yeah. So I think it's a hybrid of intuition and method. Yeah.
So from this question, I'm very interested in the relationship of creativity and technology. And in this way that you're working, do you find that these technologies that you're using are influencing what, like the way you create?
I do. I think that when we were in early design for En Pointe, I think only now because I know so many technologies now. Like I've studied mold making really carefully. I've studied metal fabrication, garment making, ceramics. I mean, I study everything pretty intensively, and then I'm just sort of gathering information for possible future deployment. And oftentimes, like even in the mold making studio, I was teaching students garment making because those techniques allowed them to unfold and then three-dimensionalize things. So there's certain forms of knowledge that are arrested in our traditions that I think if you use them, just not even exhaustively, you learn things that you can apply somewhere else. So the garment making actually helped resolve some very small scale geometric issues with En Pointe that yielded a really beautiful detail where I could have had like a small scale problem. So I don't really think of it linearly. I just like to learn about things, and I find that reservoir of information helps me more quickly translate ideas through into material. So En Pointe, I knew break forming would be an affordable way to work, and so I limited how I drew to forms that I knew I could produce with developed surfaces. So it was kind of a constraint very early on, but as a younger designer, I wouldn't have known to make that constraint earlier. I would have been far less efficient.
I just wanted to ask maybe about the relationship between some of the installation work and also the work that you're doing in the teaching, which is about, let's say, an incredible amount of detail and thinking about the surface and another scale of experience, and then the house projects, which are much more about kind of volume, like outside of, let's say, the roof and its articulation or certain elements, and that some of that other work doesn't come into like that scale of detail. Is that something that has to do with the relationship with the clients? Is it something that you intentionally don't do?
I've had this question lots of times because it's clearly something that is that I should answer. I think that I haven't had huge budgets for the work, and I'm so busy with my various responsibilities that I prefer not to have to build what I'm designing, even though sometimes I have to build it and I enjoy building it. The reality is I have too many responsibilities to build it. And so I think part of it is I'm interested in figuring out what other people can build for me. And I'm interested in figuring out how to do that while maintaining a relationship with the client. So, and actually being able, I don't like to not be able to build a commissioned project. I want to be able to build it. So I think my first interest is in the spatial conditions of a project, and doing that is expensive and hard. And so I think that that kind of limits my desire. I actually don't want to allow the surface to distract from those achievements. And so I think it's both a sensibility issue and also a budget issue. And then when we're actually making things, we can craft them with care. But trying to do that at the scale of a job site with a dozen different subs, it's really hard in residential construction to have good outcomes. And so I guess I'm a little nervous about it.
Hi, thank you for your lecture and for a really rigorous description of processes. I was kind of struck and surprised by something looking at the body of work that you presented and listening to the lecture, and I thought maybe this question would be a bit irreverent, but given your response to Mona's question, I hope you'll appreciate my asking. But it strikes me that there's such a joy and a sense of humor to some of your work, with the Periscope and with the sort of bulbous blob and with this En Pointe idea with these kind of impossible ballerina legs.
Right.
And I just wonder about the role of humor and just playfulness in your work as a part of your process. As somebody who's TAing undergraduate studios, I'm always find myself asking them, are you having fun yet? And I'm just profoundly curious to know how that plays a role in your process.
I think that's a good question. I like humor as long as it's not ironic. And I have a hate-hate relationship with irony that's playing out at my school currently. But I like subtle humor. So, and I really like names. So I've taught a class called Between the Sheets. I've taught a class called Chasing Skirts. I like to fabric fantasies. So I really like being also slightly provocative. So to me, like Conditions of the Succulent House are like absurd. So I think the humor is almost absurdity. And so I kind of enjoy being, I would call it more provocative. And yet there's like a lot of, there's real rigor in calling like that particular class Between the Sheets, but there's also this dual meaning. And so I don't know, I think that's kind of, it keeps me interested and engaged, and it makes people wonder what I'm up to. And I'm also quite interested in claiming forms of knowledge that have been historically associated with women and smuggling them into the classroom. So having, 10 men use sewing machines, I get a perverse joy out of doing that. So I've done lots of sort of things like that, but I don't typically explain why I'm doing it. Yeah. Thank you for your time. I went way too long. Thank you.